I'm Kazunari Shibata from Astronomical Observatory. Previous name is Kwasan and Hida Observatories of Kyoto University. And I'm going to organize this morning session. And title of the session is Astrobiology, relation between the space, universe, and life. And there are three keynote talks. First talk will be given by myself. The title is Solar and Stellar Flares and Their Impacts on Planets and Life. Okay, let's start with my talk. First flare, solar flare, that human beings observed in history was by Richard Carrington in England, and also by Hodgson in England. This is a very famous sketch by Carrington, large sunspot, and you can see white patches. This is now called white light flare because we can see this by visible light, white light. And this white light flare is a very rare, associated with a very big flare. So Carrington was very lucky to observe this one. And he was very surprised to find this very short explosive event. And this continued only for 5 minutes. But next morning, very bright aurora appeared all over the world, such as Cuba, Bahamas, Jamaica, El Salvador, and Hawaii. Of course, you know, aurora is usually observed in the northern countries, but this time, very southern places, aurora was observed. And actually, this was the largest magnetic storm in recent 200 years. And by checking the old literature, we now found that at this stage, telegraph system already started. But that system all over Europe and North America failed. Telegraph pylons threw sparks, and the telegraph paper spontaneously caught fire. So some economic disaster occurred. And very recently, in 1989, March, very large magnetic storm occurred. And aurora, very beautiful aurora appeared. This led to a Quebec blackout. This is the Quebec state in Canada. And 6 million people could not use electricity for 9 hours. And this magnetic storm is 540 nanotesla disturbance. And associated with big flare, but this is not a very extreme big flare. This can occur 3 years later or so. And the reason of this trouble was transformer trouble. Because of a magnetic storm, strong electric current flow in the ionosphere, which induces electric current on all electric system. That caused trouble in the transformer and the other electric instrument. This is aurora seen from space. You know, very bright region is aurora, Quebec. Even at Florida, aurora was observed. And such an aurora region often had trouble in history. And a very big question we have, will the Carrington class flare occur again? If the Carrington class flare occur now, what will happen? And recent paper estimates potential damage to 900 plus satellites currently in orbit could cost between $30 billion and $70 billion. So a huge disaster on our modern civilization. So question, why do solar flares produce magnetic storm on the Earth? What is a solar flare? Will our sun produce super flares, which are much more energetic than the largest flare we observed before? This is a question I will discuss in my talk. So this is the plan of my talk. So let's see, what is solar flares? This is a very big solar flares observed at Hida Observatory of Kyoto University. And observed in H alpha spectrum, right? And you see this black circle is a sunspot magnet, a kind of magnet. And you see a bright patches propagate. This is a solar flare. The actual time scale is more than 1 hour, but now shortened in a few seconds. So you can see the change of bright region very well. And as I said, the source of energy is magnetic energy stored around the sunspot. We know this physics already, but exact mechanism still not yet completely solved. And total energy release is this number, but maybe difficult to understand for you. 10 to the 32 erg is roughly 100 million hydrogen bomb energy. And often solar prominence eruption occurred in association with solar flares. This is the biggest prominence eruption in the history observed in US more than 70 years ago. You see, this is a solar limb. So this prominence is how large. And the speed is 300 kilometers per second. So we can go to Tokyo in 2 seconds with this speed. And now the physics of solar flares has been studied well. This is a famous X-ray movie of the sun taken by Japanese satellite Yoko, Japanese, US, and European collaboration. This is true nature of the solar corona. Solar corona is sometimes observed at total eclipse. The temperature is more than 1 million Kelvin. And but this movie, you can see that the solar corona is full of flares, explosion, all brightening flares. And also you can see sometimes mass ejection occurred from bright region flares. That is a kind of prominence eruption, and finally become solar wind. So I was very surprised, shocked to see this movie when I joined this research group. And this is X-ray, so very dangerous to our body. But of course we are safe because our atmosphere absorbs X-rays in a high atmosphere. But if we go to space, we will receive such X-rays, strong X-rays and other radiation particles. So very dangerous. And also, this is the American and European artificial satellite observed the artificial eclipse of the sun in space. So this is a circle is the sun. This is the metal circle. You see corona, also stars. And immediately we can find that corona is flowing out. This is a solar wind. And sometimes gigantic mass ejection occurs. This is a result of a prominence eruption and called coronal mass ejection. So we usually don't know such a very active solar situation, but such solar wind and the coronal mass ejection sometimes impact the Earth. So if such a huge mass ejection directly collide with the Earth, what would happen? This is actually, sorry, in Japanese newspaper, 16 years ago, very big flare occurred near the center of the sun, and mass ejection collided with the Earth. So produced a lot of troubles in our society, modern civilization, such as trouble of artificial satellite, trouble on the sea, ship, electricity blackout, radio communication trouble, aurora, and finally, newspaper describes even the airline passengers receive radiation dose, a bit dangerous. Why aurora and magnetic storm occurred as a result of solar flares and coronal mass ejection? This was made by NASA animation. When big solar flares occurs, huge mass ejection occurs, coronal mass ejection, and reach the Earth 2 or 3 days later. And once geomagnetic field stopped, but finally energy can enter to the North Pole, around North Pole and South Pole. This is the aurora. So this is the way how magnetic storm and aurora occur. And now international solar observation is very developed. This is the stereo observation of the sun and the earth. So solar disturbance, blast wave, can now be directly observed. So we can see how the earth is in a dangerous situation. And from these kind of data, now we should develop a space weather prediction. Prediction of a space storm as a result of solar flares and solar wind. This is an urgent issue in all over the world. Okay, so from now, I'll show you one entertainment on the solar flares and mass ejection using the Kitaro-san, famous musician, Grammy Award winner, his sound simultaneously. And please enjoy nice music and solar movies. You can understand how a sun is active. And if you want to see this movie again, you can buy this one in Amazon. So this is a collaboration between Kitaro-san and myself. And you can buy both the English version or Japanese version. Okay. As you see, the sun affects the Earth in many different ways. And summarizing, solar flare produce X-rays, strong X-rays and ultraviolet. This reach the Earth in 8 minutes. And then energetic particles come to the Earth in shortest time, 10 minutes to 2 days. And finally, solar wind disturbances come to the Earth as a result of prominence eruption, coronal mass ejections. And these produce a lot of trouble, as we discussed. And now we need a space weather prediction, and this is the center of the space weather prediction in United States, NOAA. And I visited this place 10 years ago, and then found an interesting presentation. You see how space weather affects you. Many electric instruments are damaged. But you can see this strange one. What this? This is denshabato, carrier pigeon. And why carrier pigeon is affected? Because carrier pigeon can travel over 1,000 kilometers because they can detect the geomagnetic field. But when the solar flare occurs, geomagnetic storm occurs, magnetic field, some change, then pigeon cannot go to the right way. And so this kind of business is affected by solar flare very much. So I heard American group of this carrier pigeon always checking solar flares. Then in 2008, in IAU regional meeting in China, I heard a very interesting, strange talk by Russian researchers. He described when solar flares occurred, traffic accidents occurred more frequently, and patients' health in the hospitals became worse. And he proposed heliobiology, new research subject. And I was very surprised. At this time, I was doing a chairman. And then I immediately asked him why. And he said, flare occurs, geomagnetic storm occurs. Then such a magnetic disturbance affects the blood because hemoglobin in blood has an ion that is affected by a magnetic field. And then blood pressure may change. So traffic people cannot control car, and also patient in hospital blood pressure change, so worse for health. Then amazingly, 1 month later, again in other IAU symposium, one Bulgarian researchers showed this interesting graph, the relation between blood pressure and the geomagnetic storm strength, and some positive correlation. And again, I was very surprised. And returning to Japan, I happened to meet Dr. Tsutomu Nishimura and Professor Fukushima in Kyoto University Hospital. And they have been studying the effect of magnetic field on life. And today, fortunately, Dr. Nishimura attending this symposium, and he will give a talk next to my talk. Then I'd like to discuss final question. Will our sun produce super flares which are much more energetic than the largest solar flare we observed before? This is a well-known statistics of occurrence frequency of solar flares, microflares, nanoflares, small flares. And observation showed that frequency of flares decrease with increasing energy of solar flares. When the energy becomes 10 times, the frequency becomes less to 1/10. Interestingly, this is very similar to the statistics of earthquake, very similar. And this is the largest solar flare, Carrington flare in the history. So question is whether this curve continues and even much bigger solar super flare occur even though the frequency is less. So even frequency is small, if this happened, this would affect the Earth, our society, very extreme. So very big disaster occurred all over the world. All electric system may have been broken, so on. So we started this kind of subject. And as you know, the Earth history is even longer. So during such a longer time, super flare, solar super flare may have affected the life, evolution of life in the past. And we know dinosaurs extinct 6500万年前0.65 100 million years ago. Of course, there's evidence that big meteor impact, that is a cause of extinction of dinosaurs. But the different possibility may be present. I started to discuss. Then my friend, archaeobiologist, showed me this graph. Life already experienced 5 mass extinction in a 540 mega year period. And the last one is a dinosaurs extinction. So there's evidence of big meteor impact. But we don't know the reason of the previous 4 times mass extinction. And a very big superflare may be the reason of this extinction. And if so, solar superflares may affect the evolution of life very much. And also recently, astronomy discovered many exoplanets. And we are very interested in the life on such exoplanet. But evolution of life on exoplanet may be affected this kind of one. So superflares is important in astrobiology subject. Anyway, we started to think about this one. Then we found that from X-ray astronomy observations, young stars show superflares with 1 million times more energetic than the large solar flares. So our sun also extremely active when that was born in 4.6 billion years ago. But our sun is not young, already 4.6 billion years old. And important point is the sun is slowly rotating. Astronomical observation already showed that slowly rotating stars are very quiet. So we discussed a bit scary subject, but please feel relieved. I discussed until 2011, 12. Amazing discovery was made in 2012 by Maehara et al. You remember statistics of solar flares. Frequency of superflares with energy 1,000 times larger than the largest solar flares might occur in 10,000 years. So in order to quantitatively establish this one, we need 10,000 years of observation. But of course, you know that our telescopic observation is only 400 years after Galileo. So how can we observe the sun for 10,000 years? Astronomer knows that there are many stars similar to the sun, called solar type stars. So if we observe 10,000 solar type stars similar to our sun for 1 year, we can get the data similar to the data obtained from 10,000 years of observation of the sun. So we started to think about this kind of analysis. And Professor Sekiguchi in Tokyo kindly told me that Kepler satellite launched by NASA, this is an exoplanet hunting space telescope. This is has established a very great discovery. A lot of exoplanets, more than 4,000 planets. And you know that recently Professor Mayor received Nobel Prize in relation to this. And this telescope, space telescope, was observing near the Milky Way here, over 150,000 stars. Roughly half are the solar type stars. And 30-minute time cadence data is open to public. So we can use this one, this data, that telescope detect stellar brightness change in very high accuracy. And we searched for super flares on solar type stars using Kepler satellite, 83,000 solar type stars. If super flare occurs, as you remember, Carrington flare can be seen in visible light. This is the visible light observation. So super flare can be detected. Since the data are so large, we asked the first-year undergraduate students to help analyzing these stars because students have a lot of free time. And then these 5 students joined our group. Here, I should mention this important point. Previously, normal astronomers didn't believe the sun, the stars similar to the sun, do not produce super flares because old and slowly rotating. And so no one has seriously studied this possibility. But these students didn't know astronomy, so completely free from such a previous knowledge. Therefore, I encourage them, if you discover this is a great research, then they start seriously search for, and surprisingly, they found 365 super flares on 148 solar type stars. And finally, paper appeared in Nature 2012, including these undergraduate students. Okay, this is a typical example of a super flare. Vertical axis is the brightness of a star and the flare in unit of average brightness of a star. Horizontal axis is the time in unit of the day, roughly 1 month. And you can see that stellar brightness itself shows a 1% change. And this spike are super flares. So super flare can be seen in visible light, 1.5% brighter than average. The total energy is estimated 10 to the 35 erg. This is roughly 1,000 times bigger than the largest solar flare. This is the other super flare. This is a very big super flare. Total energy is 10 to the 36 erg, 10,000 times bigger than the largest solar flare. So, and interestingly, these super flare stars show stellar brightness variation itself. Very interesting. All super flare stars show such a brightness variation. Why? We hypothesize it is likely due to the rotation of a star with a big star spot. This is a calculation by undergraduate students. If such big spot is present on stars with a rotation, stellar brightness become like this. When spot is backside, the star become most bright. But when spot is here, stellar brightness decrease. And this is a very simple model, but amazingly can explain observed brightness variation. This is not a proof, but shows the possibility of this mechanism. Okay, so this is our hypothetical image of a super flare solar type stars. This white region, bright region, is a white light flare, similar to Carrington flare, but much bigger. And the star spot itself also very big. Then huge energy is stored in the super flare occurs. This is a big solar flares, real image observed at Hida Observatory. Okay, so maybe we should discuss frequency. This is the result of stellar super flare frequency. So interestingly, roughly this statistic is a continuation of solar flares. So super flares of 1,000 times more energetic than the largest solar flare occur once in 5,000 years. In the case of 100 times frequency, the once in 500 years. So this frequency is not much different from a big earthquake frequency, such as big earthquake occurred in eastern Japan, 2011. So this is not 500 years later problem, but modern, present problem we should know and prepare. And some researchers also searched for the evidence of super flares on the sun. Dr. Miyake discovered evidence of cosmic ray increase roughly 1,000 years ago. Now this is interpreted as a result of solar super flares. And on the other hand, Dr. Hayakawa in Department of Literature found this kind of old evidence of aurora written in old literature. This can be larger than the Carrington flare. Okay, so summarizing my talk, large solar flares with energy 10 to the 31 to the 32 erg often produce disaster on Earth through geomagnetic storm and solar energetic particles. And radio communication trouble, global blackout, and even health problem of life and human. And using Kepler data, we found many super flares on solar type stars. That means possibility of solar super flares in this frequency, and there is also recent evidence in tree ring and old literatures. Thank you very much.